Welcome, geometry students, to the Chapter 4 practice test. You can find it on page 231. We'll get right into it. Start with number 1 here. Triangle with no sides congruent. We're trying to choose the letter of the type of triangle that best matches each phrase. So just a simple matching exercise here. It looks like number 1, no sides congruent would be a scalene triangle there. So I'm going to say that is choice B. Number 2, triangle with at least 2 sides congruent. That's the definition of an isosceles triangle. That's choice A. And number 3, a triangle with all sides congruent. That's the definition of an equilateral triangle. So B, A, and C for 1, 2, and 3. Number 4, to identify the indicated triangles in the figure, if PB is perpendicular to AD, it looks like they have that labeled right here already, and PA, segment PA, is congruent to segment PC, also labeled here and here. So identify the indicated triangles in the figure. Which one would have to be isosceles for number 5, obtuse for number 4, right for number 6. So it looks like for number 4, and there may be more than one, so we'll check and see as we go through that. So this is for questions 4 and 6 for this figure. Obtuse would definitely have to be, since this right here is a right angle, if we have another segment here that's to the right of that right angle, this would have to be an obtuse angle. So PCD, you could list those letters in any order, but PCD would be an obtuse triangle. Let's see if there's any others in there. It looks like this would be acute, this one. These other ones would be right triangles. That's the only obtuse triangle that I'm seeing. Number 5, isosceles, would have to be this one, PAC, because you have 2 congruent sides right there. So triangle PAC, or those letters listed in any other order. Am I seeing any other isosceles? I don't see any other isosceles. Nothing tells me that this side has to be the same length as this side, and likewise any other sides other than PA and PC. Nothing listed there tells me that those would have to be any other congruent sides that are there. And then a right triangle PBC clearly is a right triangle. So you could say triangle PBC. But you could also say on this one, since that's a right angle and you have a linear pair right here, that would also have to be a right angle. So you could say that one, and you could also say triangle PBA or PAB would also work. So I'll go with PBA. That's another right triangle in that picture. And then 7 through 9, find the measure of each angle in the figure. We've got 1, 2, and 3 right over here. It looks like for number 7, that's a linear pair, 1 and 100, so that's clearly got to be 80 for that one. And that is just 180 minus 100. Number 8, if that one, I'm going to label it as I go here. If this one was 80 degrees, and we have to find 2, it looks like we've got, that's going to be another linear pair right there. So 180 minus 75, that's 105 degrees then right there. So this one, 105 degrees. You can just say that is 180 minus 75 if you had to show work or justify your answer. Number 9, if you got 105 here and 80 here, that would mean right here, this angle would be, this is vertical angles right here with that one. You've got another 75 degrees right here. So a couple of ways you could approach this one. You could either use the exterior angles theorem and say that 1 plus 3 equals 2, because 2 is an exterior angle with respect to those two. Or we could use the fact that 75 plus 80, if we take that sum and subtract it from 180, you have the 3 triangles, the 3 angles in a triangle, adding up to 180 by the triangle sum theorem. So a couple of ways to approach that one. Why don't I get a little fancy with it and use the exterior angles theorem? So I would say the measure of angle 3 plus the measure of angle 1 would have to equal the measure of angle 2. And I already know what 1 and 2 are. So that's 80. This one was 105. And the measure of angle 3 would be that. If I subtract 80 from both sides, the measure of angle 3 would clearly have to be 25 degrees. And if you check that against the triangle sum theorem, 80 plus 75 is 155. you add 25 to that, you do in fact get 180 like you would expect. And so there's a good justification for that right there. This was again the exterior angles theorem, but you could also use the triangle sum theorem based on the fact that that one has to be 75. Let's take a look at number 10, 11, and 12. So name the corresponding angles and sides for each pair of congruent triangles. If they're congruent, there's 6 parts that are matching up, and you could say that the matching letters are the corresponding parts. So we could say angle D is congruent to angle P, angle E is congruent to angle Q, angle F is congruent to angle R. So those are the 3 angles, and then the sides, just list the first 2 and the first 2, the last 2 and the last 2, and then the first and last and first and last. Those have to match up in that way. So DE is congruent to PQ. You've got EF is congruent to QR. And you also would have DF, first and last letter, congruent to first and last letter PR. Number 11, same sort of thing works. So this would be like this. Angle F is congruent to angle H. Angle M congruent to angle N. Angle G is congruent to angle J. And then first and second congruent to first and second. Second and third congruent to second and third. And finally first and last letter congruent to first and last letter over there. And one other one here, angle X congruent to angle Z. And from this one to this one, you got angle Y is congruent to angle Y, and you have angle Z is congruent to angle X from this triangle to that one. You would say XY is congruent to ZY. You would say YZ is congruent to YX. So the second, or the last two letters, and then first and last, XZ, congruent to first and last in the other triangle, ZX. Moving on from there, number 13 is determining whether these triangles are going to be congruent given that these are the coordinate points. So I'm going to add a little grid on the back of this here. And so from there, if I draw coordinates, looks like -7, that's the farthest I go in any direction. So if I go 7 in each direction, I'll be guaranteed to fit everything on here. So I'm going to go something like that. Looks like it'll definitely be enough room to fit everything on there. Alright, we got that. And let me keep using black for the axes. And now I'll plot my points in blue. I'll go blue with this one, and I'll go green with this one. So J is at -1, -2. K is at 2, -3. And L is at 3, 1. So here is J, K, and L. And then in green, I've got -6, -7. So back 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7. That is M. And -2, 1. Well, if I'm just thinking about that being the length of the triangle, there's nothing that's even close to being that big over there. So I'm definitely thinking these are not congruent triangles, but we'll see what else we got here. So 5, 1, 2, 3, 4, 5, and up 3. This is P. Let me connect those with some segments. So this is triangle JKL right there. And this other one, connect in green here, this is M, and I'll label that as an N in just a second. Looks like I forgot to write that in there. So like that. And so let me just say that obviously these are not congruent. start like that, but on a test, if you're one of my students, it probably won't be quite this obvious whether or not they are congruent. You'll have to make something like this, some right triangles off to the side, or use the distance formula. One of those two ways will work, but if you use the way I showed you most of the time in class, if you're one of my students, we did something like that, where we made right triangles off the edges or the segments of the given triangles, and we just determined how big these were. So this one was 1, 2, 3, 4. This is a 4 by 1, 2, 3, 4, 5, 6, 7, 8. So a 4 by 8 right triangle right there. If you look at these other ones, on the blue one, you've got a 4 by 1. Yep, this is 4, this is 1. You've got a 1 by 3. And you've got this is 1, 2, 3, 4 by 3 right there. So a 4 by 3 right there. You can do that with these other sides as well. So this is the idea. This is what I'm looking for on a test if you're one of my students, that you're showing me that the right triangles are the same. So 1, 2, 3, 4, 5, 6, 7. And then this one, ooh, that's a big one right there. But this is up at, oh, what is that up at? That's at 3, and this is going down to -7. So that's 10 right there, and this y value, or this x value, is 5. This one's at -6, so that's 11 if we count the steps there and there. So what I'm really looking for on the test is that you can show me the lengths of that. So I'll do that here. So the lengths of all the sides, jk squared would equal 1 squared plus 3 squared. So that means jk, we would square these, you get 10, and then take the square root of both sides, you get the square root of 10. For kl squared, you'd have 1 squared plus 4 squared, and so that means kl would be, you square these, combine them together, you get 13, so it would be the square root of 13. And likewise, you'd have for jl squared would equal 3 squared plus 4 squared. So you'd have jl is 25, jl squared is 25. That means jl is the square root of 25, which equals 5. So you have this one, and this one being the lengths of your legs for the blue triangle. And then on the green triangle, you have mn. You square mn, you have 4 squared plus 8 squared, and that would be 64. What am I doing there? Yikes. You've got 64 plus 16, so that's a square root of 80 after you take the square root of both sides. And if you're doing simplified radical form, this would be 16 times 5. You could pull out a 4. So 4 radical 5 would be simplified radical form. Mn, you'd have what we have there. NP, though, that's what I meant to say. NP squared would equal 2 squared plus 7 squared. And so that means NP would be, this would be 4 plus 49. So that's 53, the square root of 53 for NP. And MP squared would equal 11 squared plus 10 squared. It's 100 plus 121. So MP would be the square root of those two added together, the square root of 221. And so these three values clearly do not match up with these three values. If they did, you would have congruent triangles, but since they do not, you would say they are not congruent triangles. So are they congruent? I would say not congruent, since the segments or the sides are not the same length. So not congruent is our answer, and then after that is the explanation. Number 14, writing a flow proof. So number 14, given this is true, we're using this for question 14. So we are given that JKM is congruent to JNM. And I'm going to try to prove, so that's JKM, this one is congruent to this one. I'm going to try to prove that JKL is congruent to JNM. NL. So if I know that these two triangles, I'll do this in a little blue highlighter here. If I know that this triangle here is congruent to this triangle down here, what I'm trying to get at is that then this triangle here, this green triangle, is congruent to this one right here. That's what I'm trying to get to eventually. So I'm going to put my given information in the picture. I'm going to get rid of that highlighted stuff for right now, just because I think it'll be easier to see what I've marked up on the picture. So given that this is true, let's make a flow proof here. And so we're doing statements in the boxes and then the reasons underneath those boxes. So this is J and M and JKM. This is true for number 14 because it is given to us. Since that is true and we're trying to prove those green triangles, what I had there initially, are going to be congruent, JKL and JNL, we could say, since this triangle is congruent to this triangle, this side and this side would have to be congruent. And you could also say, oh, what else? That this angle and this angle, that would also be helpful, that those two things are congruent. So those things match up in these two triangles. So why is that? Well, if we're given that the triangles are congruent, we can prove that corresponding parts are also congruent. So this idea, or these two ideas, flow from this one, the fact that JK is congruent to JN. That flows from the thought that those are congruent triangles by CP, CTC. Corresponding parts of congruent triangles are congruent. You can also say CPOCTAC if you prefer that. And we've got also that the angles that I've marked up there are congruent. So KJM is going to be congruent to NJM. And why is that the case? Same reason. So CPOCTAC or CP, CTC. Now, since that's the case, we kind of have this other idea just floating off on its own here. We can prove, this was something actually that I've been, if I'm going to stay consistent with what I had been doing in class, so I'm going to use red to prove extra stuff. So I could say that this and this is extra stuff I could prove based on either what's clear in the picture or what's clear based on given information. I could also say that this segment, JL, is shared by both those triangles, JKL and JNL. That means by the reflexive property that this side would be congruent to itself. So JL is congruent to JL. And this stuff, really I had meant to write that in red, but we'll just leave it there. I think we're okay with that, I hope. So JL is congruent to JL. This is a totally separate idea. Nothing that was given is leading me to believe that. Just the picture is leading me to believe that this has to be true. So the reflexive property tells me that JL has to be congruent to itself. And now I have side included angle and a side matching with the side included angle and a side in both of those larger triangles right here, JKL and JNL. That means all three of these ideas can flow together to tell me that what I'm trying to prove is true, that JKL is congruent to JNL by side, angle, side. Let me write that S a little nicer there. So side, angle, side. And then for 15 and 16 we are using this picture. So 15, not having to write a flow proof or any type of proof for this one, but I am given some information here. So FJ congruent to FH, that's right here in the picture already. GF and GH also congruent in the picture already. And if the measure of JFH is 34, so JFH, saying that this angle is 34 degrees for number 15, find the measure of angle J. Well, if this is an isosceles triangle, we can prove that this angle and this angle have to be the same. That's the isosceles triangle theorem, and then there's that deals with base angles at least. So the isosceles triangle theorem dealing with base angles tells you that those two things are congruent. That means for number 15, you would have 180 minus 34. If you take that and divide it by 2, you've got the portions there. We're trying to find the measure of angle J. So that would leave us with, let's see what we're left with there. That would be 146 over 2, and that would be 73 if you divide that. So it's 73. That's the measure of angle J. And number 16. Now it looks like GHJ. I'm going to erase what I had there because it's not necessarily saying that what's true in 15 is true in 16. So let's get rid of that and start over again with that picture. And let's see, we got GHJ, this whole thing from GHJ to connect the dots. So we've got that whole angle from there to there. It's 152 degrees. We're given that. The measure of angle G is 32 degrees. So they're saying this one right here is 32 degrees. Find the measure of angle JFH. So definitely aren't using that same thing. There would be nothing to figure out here if that was the case. So we're looking for this angle, not assuming that this is true now in 15 to start with 16. So if this is an isosceles triangle here and here, that means this one and this one have to be congruent right there and right there. The two purple ones have to be matching up or congruent. So this is 32. We would have 180 minus 32 left over for the two purple angles together, and that would be 148 degrees for the two purple angles. So that means that the measure of angle, what is that right there, GHF, the measure of angle GHF would have to be 148 divided by 2, and that would be 74 degrees. So if this one right here is 74 degrees, and the whole thing right here is 152 degrees, I'll keep using some different colors here. The whole thing's 152 degrees. That means the measure of angle JHF right here, this angle, JHF, would have to equal 152 minus the 74. And 152 minus 74, well, 154 minus 74 would be 80, so this would be 78 right there. So 78 degrees here, and since these two are isosceles, or this triangle is isosceles triangle, we could say this one and this one would have to be the same, so that's another 78 right there. So left over for this angle right here, we would have that the measure of angle JFH would equal 180 minus, we could just say 2 times 78. And 2 times 78, that's 156. And so that leaves us with 24 degrees right there for the measure of JFH. So notice, not the same as what we started with here. We're starting with different given information for 16 than we were for 15 there. And then 17 and 18, you may or may not have been assigned these. If you're one of my students, just take a look at your assignment sheet. I'm going to do them here though, just in case they were assigned to you. So a landscaper designed a garden shaped as shown, in the figure. The landscaper has decided to place point B 22 feet east of point A, so that means this would be 22 feet right there. Point C is 44 feet east of point A. So if that's 22 east of point A, that means the whole thing's 44. That means this one would also have to be 22. So the whole thing right here, here to here, is 44 feet. Then you'd have 22 left over right there. Point E is 36 feet south of point A. So this is 36 feet. We're going to assume that's true then. And point D is 36 feet south of point C. 36 right there. The angles at points A and C are right angles, so we got a right angle right here and a right angle right here. To prove that angle ABE is congruent to triangle CBD. That's pretty easy to do based on what's here, because I can see that you have two congruent sides there, two congruent sides here, since those lengths are the same, and a congruent angle in between those two sides. So to prove that the triangles are congruent, we can use side, angle, side. If we had to do this in a two-column format, we'll do that here. I can do that pretty quickly, I think. So I'll just write that out here. We've got statements, and we've got reasons, and so step one. Boy, I'm really feeling it doesn't say two-column format. Yeah, I could just say side, angle, side, but I'll give this to you just so you have it. So we have that AE is congruent to CD, and that's essentially given in the information here, 36, 36. So I'm going to say this is given. I'm also told that angle A is congruent to angle C. They're both right angles, so they have to be congruent to each other. You could take this a step farther and say these are both right angles given, and then say that this is congruent to this by the definition of congruent angles, or by the definition of right angles, or that right angles are congruent to each other. That's another thing you could say here, but I'm not going to be that picky with this one. We're given that they're both right. Clearly they're both congruent then. And then 22 and 22, this is AB, would be congruent to CB, and this is also given. So if we're given all that information, step 4, I could say that the triangles are congruent, that triangle AB is congruent to triangle CBD by side, angle, side there in the picture. So angle is included in between the two congruent sides. That's why it is side, angle, side. And then number 18, some standardized test practice. In the figure, FGH is a right triangle. So FGH, it's already labeled there, with hypotenuse FH, so that's the longest side, across from the right angle, and GJ is congruent to GH, already in the picture as well. What's the measure of angle JGH? They tell us in the picture as well, this is 28 degrees. So if this is 28, that means the measure of angle H would have to be 90 minus 28, because there's 90 left over for these two. That one's 90, so this means that would have to be, looks like 52 degrees right here. If that's 52 degrees, this one is also 52 degrees, because this angle and this angle have to be congruent. They're isosceles, or this triangle is isosceles. That means that angle has to be the same thing. JGH, then what's left over for that? That's 180 minus 52 times 2. That's 180 minus 104. And that would be what I'm looking for. The measure of angle JGH is going to be 76 degrees. So that, it looks like I did not do something right here. So let's see where I went wrong. We've got 180 minus 52 times 52. Yeah, this isn't 52, is it? So no. 62. My bad there. This would be 62 times 62. And that's 124. And that looks better then. So this would be 56 degrees right here. So this is a 62. This is a 62 right there and right there. So 56 degrees is what that is for JGH. If you have any questions, feel free to let me know in class before you take the test. If you're one of my students, feel free to comment as well if you see any mistakes or errors. Let me know if there's anything you see wrong. Happy to reward you with some Wagner bucks if you're one of my students. If you catch any mistakes, just let me know where the time was in the video where that happened. Feel free to go back and review the lesson as needed. Maybe try it all over again and see if you got the right things. Hope you have a good day, and I will catch you guys later.